But today we're here to talk about a little bit about data science. You guys didn't vote for my class last year, but I'm not going to hold it against you. But I snuck it in anyhow. But I brought Navraj with me. I brought a real data scientist with me because I thought we'd start the discussion with how does a professor of protein molecules become part of a wireless community? And it's going to be relevant to why you should keep your eyes on this. So Navraj, maybe you give a little bit of discussion on how did you end up at a WLPC conference after being a professor somewhere simulating protein molecules?
The short answer is I love math. So I love data, and I love data science. And the problems were intriguing. When we were studying protein molecules, nobody thought about AI. You know, if you ever have any academic friends, they always fight for grant money, right? No one would ever fund AI stuff. And I thought AI was the future, so I moved to the Bay Area. And we're going to talk about what we've done.
Well, there's a little bit more to the story than that.
Okay.
He was simulating protein molecules, going to particle accelerators, getting this stuff done.
Yeah.
But what put you out of business? What made you decide it was time to change?
Well, 2 or 3 years after I left, Google DeepMind determined the three-dimensional structures of proteins just from, training a model. So, and they've done a great job. So the answer was AI. So
the moral of this story is be aware of your data science surroundings. So Google DeepMind basically put an end to its protein thing, and that's what got us into the wireless world.
yes.
And when you look what's going on around you, I would tell you real quick, if you look what's happening in every industry right now, data science is changing our healthcare, our agriculture, our thing, and it is changing networking next. And it's coming to networking in a big way. For those who know me, I started my career at aerospace, Cisco and everything. I got into the Mist venture when a couple of big customers told me, Bob, you got to stop the controllers from crashing. You got to get me some code. Can't wait a year to get code every time. And more importantly, you got to tell me if the user is going to have a great experience. And that is really the paradigm shift I think we are all dealing in a room, right? We're going from making sure the APs and the switches and the routers are all up and green. Got to keep doing that. But what's more important, we got to start to understand, are the users having a good experience on the network? I started that adventure with the APs because I was trying to answer the question of why are you having a poor internet experience? And it turns out the wireless has a lot of information to answer that question. Now, for those who've heard about, we've all heard about the canary in the coal mine, right? For us, our canaries are Zoom and Team users. I think if all the apps that we run, Zoom and Teams are the canary in the coal mine. If you look at those little people, your network is in trouble when you have your Zoom and Team users dying over in the cage, right? And so that's why I'm starting to focus on Zoom and Teams, because if you're having good Zoom Teams experience, probably means your network is in pretty good shape. The other thing I have found in this adventure is as we start to get into the data science piece of it, you have to take people like Navraj who understand all the math that goes on with this stuff, and you have to get them hooked up to your customer success, your support team, you guys, right? The people who understand how these networks are you. And my message here is if you don't get to know your data scientists, you should start to get to know them better. In the future, you're going to want to know and understand how these data scientists like Navraj can actually help you. Because it leads to things like this. When I started Mist, my first mission was to make sure that I needed to answer a question, the data had to be in the cloud. So those yellow bars represent how I had to stop the support team from SSHing into networks. And for most of you, I've talked to a lot of you guys, when you tell someone you're going to take away their SSHing or their CLI, it feels like you're stealing their lunch, right? You take those keys away, man, they will go down dying hanging on to that SSH key because they feel like they have to log in. But if you want to get into this data science cloud stuff, you got to get the data you need back into the cloud. It's important if you want to basically apply data science to it. It's also important to make sure that a broader number of people actually can see the data. You want to get as many people working on a problem as you can. The problem with the CLI is you get a very small set of people who can actually CLI into networks. So this is the benefit of actually starting to get into a cloud AI ops type of world. Now, the first generation of stuff I worked on, the paradigm shift was really around user experience and user minutes. So the thing we did originally was took all this data and organized it by user. Instead of organizing it by AP, switch, and route, everything that came back got aggregated at the user level, at an experience level, right? So we can start to answer questions about user minutes. How many good, bad user minutes am I seeing in my network? Whether it's Zoom, coverage, roaming, throughput, or something, I was trying to aggregate by the user. Oop, now I forget this. I don't need all this. This is the simple math. So Sudhir always gives me a hard time, Bob. You know, we don't need fancy math. There's a lot, and it's true. There's a lot of problems that we solve that do not require fancy math. Dynamic PCAP. There's a lot of things that we do that don't require all this fancy deep learning stuff. This is like the very first simple math we did. Believe it or not, this is simple. For Navraj, this is like, we don't waste our time on this type of stuff. This is like mutual information where we're taking bad user minutes and we're trying to figure out what network feature correlates to those bad user minutes. This is not even machine learning. This is just basic analytics. Now, what I brought Navraj up here to help me discuss is, this is what we're moving to now on going to that canary in the coal mine. Right now, you think about these Zoom and Teams users, we now have access to that data, right? Zoom and Teams provide you access to the user data coming back. And now I'm gonna turn over to Navraj a little bit to explain, you know, what is he doing with that data? What is this model? What is Shapley? What are the analytics going into this?
Thank you. So let me dissect this flow chart that we have here. In the bottom left, we have the Zoom and Teams data. So what actually do they provide us? They provide metrics on the performance of the calls. So for example, latency, jitter, and loss. So right away, that provides a lot of information, as Bob mentioned, in the form of analytics. And we see that on the top right. So this is a bar graph which shows you the sites for a particular org that I'm going to talk about, which are experiencing a bad scenario. So what I have on the x-axis of that graph is percentage of minutes that are bad, right? How do we define bad? That's the first thing. Well, we do what Zoom said. They say if your latency is over 150 milliseconds, that's a bad minute, right? If it's better than that, you should be fine. That's the recommended setting. Missed wide, we have stats on that now. It's usually around 1 or 2%. If you look closely at that graph, you're seeing sites that are 40%, almost half of, or a little less than half of their minutes are bad. So something is obviously wrong. And there's a top 3 sites, you know, even the third site you see, it's 20, 30%. So right away, so this is real data. We've spotted, okay, there's issues with this site, so we've identified it. But then, you know, what do we do next? I know what you guys do next. You have to look into all of these things and see where the problem is. That's where AI is trying to help you. It's another tool. And that's where we get to, you know, how are we going to solve this problem? Is it a client problem? Is it a wireless problem? Is it a Wi-Fi? Is it a WAN problem? So how are we going to do that? Well, we have all the data in the cloud. We have our Juniper Mist data that gives us all of this, right? The number of clients on an AP, the RSSI for that client, the CPU usage of that client, right? So we combine that with the Zoom data, and then what we try to do is, based on all of that data, we want to predict those metrics. We want to predict the latency. And the first thing you should always ask is, well, you know, that's all fine and dandy, but how good are you doing? And that's what the graph underneath on the right side in the middle shows you. And what that says is that for 80% of our calls, that's on the y-axis, we are within 10 milliseconds of predicting the latency, right? So that's pretty good. And for 90%, we are within 20 milliseconds. So we can trust our model. What is that model telling us? Give us network and client parameters, which we have, and we will be able to predict your Zoom performance. So that's pretty cool. But then all my colleagues at Juniper Mist used to say, so what? You know, you're real fancy. I love your clothes you're wearing. I don't dress like this, by the way. I did it for you. Bob can tell you that. But, you know.
Hey, you don't see me in a suit.
So what? And that's where Shapley comes in. We can tell you what is the dominant feature. We can tell you radio utilization is too high. That's what Shapley does, and it does it in an objective way. So, and that's what I want to show you.
The one thing I may add here real quick is you look at that AI model, think of ChatGPT. What he's doing right now is basically taking tons of data, just like ChatGPT did, to learn to predict something, right? And this is the power of these deep learning models. When they get big enough, you can start to predict a lot of interesting things in network. More interesting, this model is now starting to predict things in networks where we don't even have Zoom data. Once you have the model thing, you can apply it to networks that you don't have Zoom data.
So this just goes over what I said about the analytics. This is real data. These are 1 million data points that I'm telling you that occurred on February 6th, completely missed wide. So I'm not taking anything away. This is it. And what I said, the average latency is 33 milliseconds, which you see on the top left in the title. The average percent above this 150 millisecond threshold per minute is 1.79%. And we see 4 orgs sticking out, 5 to 3%. So we're going to investigate those, and we're going to do it. And now I've said, you can actually look at these, just analytics, look at a site level. So I took org 2, the second org, and I looked, one site is performing particularly bad, like 25%. Other sites are okay. Then I actually looked at the AP level for that one site that was bad, and we see, some APs are performing poorly. So we're getting more and more hints, but this is where the Shapley comes in. What is Shapley? We take all of these features of the model, and we try to see which has the biggest contribution. Now, it's objective. It knows nothing about networks, right? It just gets everything from the data, and it looks at every single combination of all these features to see which one sticks out. So, and you can do it whole org-wide, site-wide, AP-wide, and also for client. So we generated Shapley graphs for this, and what we found out is one feature stuck out for org 2, 3, and 4. The worst performing orgs apart from the first one. And what was that feature that stuck out? VPN distance. So what exactly is VPN distance? This is the distance from the client to the VPN server they're connecting to. So it's a client feature. And it was something that, what I show here is all of the top features that are doing. The VPN server distance was half of the problems.
Yeah. And I may tell the customer story here. So we had a very large customer 3 years ago challenge us on this Zoom call. He basically said Zoom was in their top 3 tickets of support calls that we're getting. How many people out there have where does Teams and Zoom fit into your support call? Top 5? Got any Zoom Teams calls out there? So this is where the challenge began. They had a site in India that was having consistently Zoom problems. They spent months, they could never figure out quite what was going on at that site. This is where Navraj applied the model onto that site, found out they had misconfigured a VPN gateway, right? And they're basically routing packets from India to Australia for a certain number of users. And that's why we call this the needle in the haystack problem. There's something going on, limited number of users, a lot of different internet connections trying to sort out why that's happening for that specific number of users. Next slide.
Yep, please. So just going in, so we're saying that VPN is the issue, but what you guys should say to me is prove it. So we looked, and that's what the table is in the bottom center. We looked at the data itself and do we see that signal coming out through the data? So you see if there's no distance or no VPN server, your average latency is 46 milliseconds. And for this particular site, this was this India site Bob was talking about, there's 140,000 calls. There was people connected by VPN, but to a server that was 500 kilometers away, the performance was equally good. But now we get people from India connecting to San Jose, Europe, UK, and also to Australia. And you see that the latency goes up to 154. So this is just from the data, but this is, the power of AI, it was able to figure it out, right? And that's what we could share to, show to you. And that, will become an action for our next time.
So I think the other customer story that I've seen this actually help with is there's another customer that was having interesting problems in certain stores they had in Australia, right? And same problem, trying to sort it out. Radio wasn't seeing anything. We have radios looking for interference and stuff. What this turned out to be was undetected narrowband radar. So this is a case where, this is a kind of a classic problem in the industry. We were dealing with radar. Qualcomm and Broadcom, struggle to actually detect these very narrowband radars. This is another tool now to basically start to find these radar problems that are lurking in the network.
Yeah, and we've seen it not only in the Australian, but a few other sites. And we're very interested to see if it. So I also did analysis on this. Is DFS channels in general a bad thing? And no, it's not. Actually, they're, you guys know just as well. You have to use as many channels as you want. So if you have the channel and it's unencumbered, you use it, and it performs very well. But if there is an issue and it's undetected, then you run into problems. I was mentioning, this chart from February 6th. Again, the number one problem was radio utilization and, radio interference, actually, in this case. And for this particular site, you could see that this just popped out. And essentially what we had found is that there was more than a 10 times increase in Zoom call. So they were sort of reaching the capacity of what their network was doing. So you could see, we were seeing issues with, number of clients on the AP, as well as, co-channel interference. But, for our next version, what we wanted to do and what our RRM team wants is, for feedback, they want more granular information. They want to know more about the non-Wi-Fi components and all of the components for radio utilization. So that's coming up in the future. But the graph that I show on the left is, I just wanted to explain that more because this is to proving that your AI model knows actually what's going on. What you see here is this Shapley value. So what you can think of as Shapley value is the contribution of your latency. If you're predicting latency, it's the increase in your latency. So on the x-axis, we have radio utilization as a fraction. So 100% radio utilization is 1.0. And what you see is going from 0 to about 0.7-ish, 0.8, it's 0 in terms of Shapley, right? It's not contributing anything. But as our intuition says, it's reaffirming our intuition without imposing it on it. It's going to a high radio utilization.
We're going to give Navraj the hook here. We're getting to the Keith Bennett. So I encourage everyone, when Navraj heard that Keith there was no questions, he got very bummed out. He's from the academic world. He's used to a more rough and tough, sharp elbow crowd challenging him on his math. So I encourage you guys all corner him and give him a little bit of work over here. You guys are way too nice. We got to get those, make sure these guys don't get soft on us and everything. With that, I want to say it definitely today is a smell the roses moment. That's my other favorite saying, And for those who know me, when I say smell the roses, that really means drink wine. So a little bit together. So look forward to getting to know everyone a little bit better. And thank you, Keith. And next one.